Using the property of determinant, prove that. Okay, a determinant is given, then questions ask prove this determinant equals to this expressions. Okay, left hand equals to right hand or not. And to solve this type of questions, okay, first either we have to use C1 equals to C1 plus C2 plus C3. If their sums come same, then we apply that formula. Okay. If it is not coming same, then we will use another step. Another formula is R1 equals to R1 plus R2 plus R3. If the sum comes same, then we use that formula. If the sum of C1 equals to C1 plus C2 and R1 equals to R1 plus R2 plus R3 are not same, then we use another way to solve this type of questions. Now, 1 minus whole cube means how to get 1 minus whole cube. How many factors required? So, what multiply or factor they could convert into this expression. 1 minus whole cube means 1 minus x, then 1 plus x plus x squared. After multiplying these two, you will get the 1 minus x cube. That means this is a cube minus b cube formula. That means if you get any one factor from these determinants, we can take as common. Okay. 1 minus x cube means 1 minus x, 1 plus x squared. From this, if you got any one of the factor, the whole square is there. Okay. If you get any one of the factor from here, when you simplify, we will take that factor as common. Now let's see. Try to use C1 equals to C1 plus C2 plus C3. If your sum comes same as according to the right hand side, then we will take that as common. Okay. Then other if that sum is not same, then use R1 equals to R1 plus R2 plus R3 and take their sum. If their same is same, then we use that formula. And that term is there in the right hand side, we will take that as common. Okay. Now I'll explain by solving these questions. Now left hand side 1 x squared 1 x, then x squared 1. Let's utilize C1 change to C1 plus C2 plus C3. C1 plus C2 plus C3. Let's say the sum becomes same or not. Okay. C1 plus C2 plus C3 means adding vertically. This plus this plus this. And if we are using row 1 plus row 2 plus row 3, then add horizontally. This plus this plus this. Now let's see. C1 1 plus x squared. 1 plus x plus x squared, 1 plus x plus x squared. That means all the sum is same. Then if the sum are same, we use that formula. That's property 2. That's operations to solve this type of determinants. Now after applying, you can use R1 equals to R1 plus R2 plus R3 also. Let's say 1 plus x squared plus x, 1 plus x squared plus x, 1 plus x squared plus x. That means whether you use C1 change to C1 plus C2 plus C3, or R1 change to R1 plus R2 plus R3 is same, but I will use here C1. C1 change to C1 plus C2 plus C3. Let's add 1 plus x squared. 1 plus x squared. We are adding all these three columns at C1. Then here also, let's write 1 plus x squared. 1 plus x squared. Here 1 plus x squared. 1 plus x squared. Then so other columns remain same. We are changing only first column or C1. Others is remain same. X 1 x squared. Then x squared x 1. Now see, all the sums are same. If the same factor is there in right hand side, we will take that as a common. Is there same factor is there? Yes, 1 plus x squared is there. We will take this factor as common from determinant. We will take this as out of determinant. Okay, common. Let's take this common. What is common? x1 plus x2 plus x square. Sorry, 1 plus x square is common. We'll take this common from C1. Now write whatever you are doing, please mention here. Okay. Taking 1 plus x square common from C1. Okay. And 1 plus x square we are taking common. Now what is left from here? 1, 1, 1. Others remain same. x1, x square, x1. Okay. If any rows or columns are 1, 1, 1, then we can make easily 2 zeros. Because our main concept to make 2 0 within the determinants among any rows or columns if possible. Okay. Now how to make 0 here? R1 minus R2, 1 minus 1, 0. R2 minus R3, 1 minus 1, 0. Now we use that formula, that operations to make 0. That means first we change R1. R1 change to R1 minus R2. And second, R2 change to R2 minus R3. Okay. R1 change to R1 minus R2, then R2 change to R2 minus R3. At that time, we will do maximum 2 operations. Okay, not more than 2. If you are using common to use 2 operations together, then use 1 by 1. Now, 1 plus x square. What we are doing? R1 change to R1 minus R2. That means 1 minus 1. 1 minus 1, then x minus 1. X minus 1 and then x square minus x square minus x. Okay, R1 minus R2, 1 minus 1, x minus 1, x square minus x. Now second operation is R2 change to R2 minus R3, 1 minus 1, 1 minus x square, x minus 1. That means 1 minus 1, 1 minus x square, 1 minus x square, and x minus 1. X minus 1. Then third row is same because there is no change in third row, only change in first row and second row. 1 x square, 1. Let's simplify. 1 plus x square, then 0, 0, 1. And what do we need? Look at here. Always take the right hand side. If possible, we take the same factor as common. Okay. What is there? 1 minus x. But in our simplification, in our determinant, what is there? X minus. Can we make this 1 minus x? Yes. Just if there is a look at here, if a minus is there, if you want to make b minus a, then just take the minus common, then do b minus a. Okay, that means let's change here. What we need? 1 minus x, that's why we are changing their place, minus 1 minus x. Anything is common to take here? We can take x as a common. After taking x, it is x minus 1. But what we need? 1 minus x. That means change the place. If you want to change the place, please take the minus and as common. Then x, 1 minus x. Then it is possible to use formula. Yes. 1 square, a square minus b square formula. That means 1 minus x or 1 plus x. Here, can you change to make 1 minus x? Yes. Take minus common and change it. 1 minus x. And third row is remains same, x square 1. Now look at here. Is there anything same to take common? Yes. R1, 1 minus x, 1 minus x, we can take this common, and same thing is there in the right hand side. That's why please expand this one if possible. Okay. 1 minus x cube means 1 minus x, 1 plus x square, because this is a cube minus b cube formula. I am using a minus b cube to expand. Now, if the same factor is there in the right hand side, we will take that same factor as well. out of the determinant, that means we will take the common. Okay, we are taking the common 1 minus x from R1 as well as from R2. Okay, because same is there, 1 minus x R1 and 1 minus x in R2 is there, we will take the 1 minus x common from R1 and R2. That means we are taking 1 minus x whole square common from both the row into. Okay. Then 1 plus x square. Then we are taking 1 minus x as common, 1 from R1 and 1 from R2. That's why 1 minus x whole square. Now what is left here? 0. Then minus 1 minus x. 0. What is left from here? 1 plus x minus 1. Then 1 x square 1. Now, after taking the common terms of the determinants and after making two zeros along any row or column, you can expand it. Because after making zeros, expanding is easy. So if you expand directly, it is very difficult to simplify. That's why we are using property to make the two zeros. At the same time, we are taking the common out of the determinants. Okay, according to the right hand side. Now we are going to expand along C1 because two elements along C1 is 0 and third element is there. Expanding along C1. Okay, expanding along C1. 1 plus x square. Then 1 minus x whole square is there. Now no need to do for this 0, 0. 0 multiply any minus 0. 0 multiply anything is 0. 0 multiply anything is 0. Then we will do for only non-zero number. That is for this one. First 0, second 0. Then we will do for this one. And what is the position of this one? This is third row, first column. That means 3 plus 1 is 4. 4 means even. 1 means their sign is plus. The plus and get the minor of this one. Okay, 1 is there. And what? How to get the minor of this one? Okay. This is third row, first column. Okay, third row, first column. Third row, first column. Okay, what are the left? That is called minor. That means you can hide this element from both the sides. Now what are left? That are the minor. Okay. Now what is left from here? Minus 1 minus x, 1 plus x minus 1. Now 1 plus x square, 1 minus x whole square, then 1 is there, 1, then minus plus, 1 1 is 1, then if after multiplying one of the diagonal, opposite diagonal to multiply another pair, there is a minus. Okay, the minus there is the formula. Then use that minus and this minus. That formula minus and this minus, plus. Okay. I will show you here. If the minor is there, A, B, C, D. Then to get this expand and A into D, then minus C into D. Okay. After multiplying this one of the pair, minus plus 1 1 1, and to multiply another pairs. Before that, there is a minus sign in between. Okay, and that minus and this minus, that formula minus and this minus is plus, and x into 1 is x into x is x square. Okay, now 1 plus x square, 1 plus x square, twice is there, we can square it. Okay, then this 1 plus x square whole square, because twice is there. Then 1 minus x whole square. Now let's take the same power as common power, because square is there, we can keep them as common. Then 1 plus x square, then 1 minus x, their whole square. Now look at here, 1 plus x square, 1 minus x, 1 plus x square, 1 plus x square, 1 minus x. This is formula, and this means 1 minus x cube. Okay, this is equals to 1 minus x cube whole cube. Now we got the right hand side equals to right hand side. This way you have to solve the determinant questions, and before going to solve the determinant questions, you have to use the different type of property to convert into simple form. After making the two zeros along any rows or column, then from there expand it and simplify to get the answer. You can't expand directly. If you want to expand directly, it is so complicated to simplify. That's why we are using the property of determinants to convert into simple form. Okay. After going through this video, please try to solve all the questions. There are many questions there in textbook, and try to solve the example. Also, example is very important. And if you need some kind of help, please comment us. We'll follow your suggestion. Okay.